So here's a situation that's a little bit more complicated where we're going to combine everything we learned about pulleys and inclined planes. So here that alpha symbol is the angle of inclination of an inclined plane. Here's a pulley system, and it looks like this pulley system is going in that direction. So this object is sliding down the ramp and pulling up an object. So how would I create a mathematical relationship that describes that? Okay, so let's draw the free body diagrams, or at least the forces that's involved. That's the force of gravity. That's my normal force. And then that would be my force of tension acting in the opposite direction. That is being caused by the force of gravity of object 2. And that arrow would be my resultant force acting in that direction. So if this object is accelerating in that direction, then I would say that my Newton's second law would look something like this, where my F resultant minus the force of tension in that direction, which is actually the force of gravity on the bucket. So I'm going to just label that FG2 is going to equal to mass times acceleration. Now, I'm assuming that there's no friction. Okay, so I'm just trying to keep it as simple as possible. Imagine this is a frictionless inclined plane. So we didn't factor friction in. So how would I do that? F resultant, as we know, is equal to mg sine theta, according to that triangle. If you remember the triangle that we drew from the last video, that's my resultant. Okay, that's my angle, that's FG, and that is Fn. Okay, so if I'm trying to solve for my resultant, it's going to be the opposite over my hypotenuse. So the resultant is going to be mg sine theta, and the m that we're talking about here is m1 in the diagram, minus m2g is equal to m1 plus m2, that's part of the pulley system, is equal to my multiplied by the acceleration. So if I want to solve for the acceleration down that pulley system, I have to isolate for it. And then that's what we have. So we've created a mathematical relationship to calculate the acceleration of a pulley system on a ramp. Okay, so if I look back up here, the acceleration that we've just calculated looks at the resultant force subtracted by the force of gravity, okay, divided by the total mass of the pulley system, gives me that relationship.